Welcome back to Polytechnic TRB Chemistry. Now, in Polytechnic TRB Chemistry, Unit 1, we are going to discuss. There are about 10 questions I have given already to the test batch. So, test batch கொடுத்த அந்த 10 questions now we are going to discuss here. First unitல இருக்கக்கூடிய முக்கியமான points, very important key points we are going to discuss here. There are two portions are there in the first unit. One is analytical chemistry and another one is analytical techniques. The first part இருக்கக்கூடிய portions அப்படின்னு பார்த்தீங்கன்னா this is actually the UG portions. BSc syllabusல இருந்து வர்றது அந்த first portion. For those things we can get from the UG portions. Second part அப்படின்னு பார்த்தீங்கன்னா வந்து those things we can expect from PG portions. For those things books பார்த்தீங்கன்னா வந்து we can get it from Skoog and Hola. There are some parts we can also get it from Puri and Sharman Patania Physical Chemistry. That book is much more useful to you. Now we'll discuss the questions one by one. The first question, it is the diffusion current is dash proportional to the concentration of the analyte. This is from the analytical techniques. Second part, from the second part only we have taken some important key point questions. இதுக்கு முக்கியமானது ஒரு equations நம்ம PGல படிச்சது Ilkovic equations. ID is equal to ID is the diffusion current, right? ID is diffusion current, average diffusion current 607 n d power of m power 2 by 3 t power 1 by 6. ID is the diffusion current, n is the number of electrons required per molecule of the electroactive substance. D is the diffusion coefficient. M is the mass of the mercury flow from the DME. DME means dropping mercury electrode. T is the drop time. It is also depends upon the time, temperature that we don't mention here. Okay, ID is also depends upon the temperature that we don't mention here, but these are the important things. From the things number of electrons, we can say that the diffusion current is directly proportional to the concentration of the analyte. This Ilkovic equation we have to keep it on our mind before the exam. Now the next question, this is polarigram is a plot of or a graph of dash against the dash. That means what will come in the x-axis and the y-axis. There are so many graphs will come for our PG chemistry and Polytechnic TRB chemistry. The physical chemistry also there are so many graphs will come. For those things we have to learn about the x-axis, y-axis, x-intercept or y-intercept, and the slope also we have to learn. We can expect question from those things. In this polarigram is a plot of x-axis and y-axis. Here polarigram is a plot of current. We are measuring the current here against the applied voltage. Current, we are measuring the current against the applied voltage. Here the x-axis we have to mention, we are using the applied voltage. The y-axis we are measuring the current. The top one, this portion is the limiting current. Here this is the ID current. From here to here we measure the ID, and ID off is also here. ID off is a quantitative purpose. We can use it for the quantitative purpose. There are also other current, diffusion current, migration current, limiting current. Those things are there that we have to study before the exam. The next one, and this is also from the polarography. Oxygen is present in the solution. It can be removed. In the solution, in the analyte solution, oxygen is present. That we have to remove before the experiment. How to remove this oxygen? There are two ways are there. One is the oxygen, dissolved oxygen in the sample solution, or sample solutions la irukkudiya oxygen எப்படி remove பண்றது. by bubbling or passing nitrogen gas. We know that nitrogen is an inert gas. While passing this inert gas, oxygen can be removed, or by using alkaline pyroglass. These are the two methods we can use. There are also so many interesting points, so many important points in the polarography, like migration current, how to eliminate this migration current and limiting current, and those things are there that we have to even these things we have to study before the exam. Now, fourth question is a stationary phase in chromatography. This is one important question. Stationary phase, these questions they have asked in the Polytechnic PGTRP question in 2019, but there they have given the stationary phase is liquid. The liquid or the solute solvent we are using is the stationary phase they have given, but in most of the books they have given as the paper. The paper which is used is a stationary phase. In most of the reference books it is given as the paper is the stationary phase, and the mobile phase is the solvent we are using is the mobile phase. Now the fifth question, the movement of the solvent moves up in the paper chromatography. The solvent means here the mobile phase. Why the mobile phase moves in a paper? Normally in a column chromatography பார்த்தீங்கன்னா the mobile phase moves from top to bottom. Why? Because it is because of the gravitational force. But here in the paper chromatography, why the solvent moves from the bottom of the paper, it moves to the upper position. Why it moves? Because the paper is made up of cellulose. The paper is made up of cellulose. The solvent we have kept in the vessel, it moves because of the capillary actions. These questions we can expect for our examinations. Okay, right? I'll go to the sixth question. In normal phase chromatography, the more polar component comes out first. That means elute comes out first or last or relatively. First, before going to this question, we have to keep one thing. What is the normal phase chromatography? Most of you know that, even though I will you repeat again. What is meant by normal phase chromatography? Normal phase means we know that there are two phases are there. ரெண்டு phases இருக்கு இல்லைங்களா? அதில் ஒன்று வந்து stationary phase, another one is mobile phase. If it is a normal phase இருந்துச்சுன்னா stationary phase தான் முதல்ல நீங்கள் calculate பண்ணலாம். Stationary phase is a polar one. அது எப்படி தான் மைண்டில் வச்சுக்கணும். If it is a normal, instead of phase we have to use the polar. If it is a normal, the stationary P and P. Like for this here, since it is a normal phase, the stationary phase will be polar. So the column is packed with a polar substance in normal phase chromatography. இப்போ நம்ம வந்து mobile phase வந்து போலாரா இருந்துச்சுன்னா, if the mobile phase is polar, it interacts with the polar substance in the column. So because of this interaction, it moves slowly out of the column. So generally it comes relatively lost in the column compared to the non-polar substance. If it is non-polar, it will not interact with the column substance. So it will comes out first. If it is non-polar, it comes out first. If it is polar substance, because of this interaction, it will comes or elute relatively later or lost from the column. Okay, right? We'll go to the next one. This is the seventh one. RF factor, RF or retardation factor, have the dimension of dash and its value is dash, and its value is lower for dash solutes. This thing is for the paper chromatography and for thin layer chromatography, TLC. Okay, TF, RF or retardation factor. We can also use this for TLC and for paper chromatography. So this is like a paper chromatographic thing. The bottom you will draw a line using a pen or pencil, and you'll put a drop of the solute on the line. Okay, after that we will dip the paper in the solvent we have taken. Here the solvent will move up because of the capillary action I told you before, moves up in the paper, and it will move the longer distance, and the solute will dissolve in the and the solute we have put in the over the line dissolve in the solvent and move slowly after the solvent phase. So RF is the distance traveled by the solute in the numerator and the distance traveled by the solvent in the denominator. So RF is always less than 1 because the denominator is the larger value. So RF is always less than 1 and its value is always between 0 to 1. One more thing, both the numerator and the denominators are distances. So RF factor is a unit. Dimension means unit I have put here. It is a unitless quantity. RF is a unitless quantity and its value is between 0 and 1. And its value is lower for எப்ப lower வரும்? If you put a polar substance here, solute வந்து polar இருந்துச்சுன்னா it will interact with the cellulose paper. It will interact with the cellulose paper, so it will not move fast. Polar இருந்துச்சுன்னா it will not move fast, so it will move very less distance and RF is also less. If it is non-polar, it will move fast and it will move longer distance and RF is also longer. So these are the things we have to keep it in our mind. Now the next question, 8th one, the more efficient the column has the peak signal. From the peak signal we have to give the properties of the efficient column in with respect to height எப்படி இருக்கும், width எப்படி இருக்கும், area எப்படி இருக்கும். From the peak signal, generally we'll say a more efficient column will be the narrower one and will give more number of peaks, will be the more efficient one. Here these are the two signals I have put here. The height is larger, it is more efficient. The height is lower, it is less efficient. It is narrower, if it is narrower means width narrower irundhuna it is more efficient. If the width is wider, it is less efficient. If it is smaller area under the base area வந்து smaller irundhuchuna it is more efficient. The base area is larger, it is less efficient. So from these also we can say the efficiency of the column. Other things also there that I told you earlier. More number of peaks and narrower the peaks is more efficient. Now I'll go to the next question, 9th one. In normal phase chromatography, the mobile phase is dash and the stationary phase is dash. This I already told you. If it is normal phase, first we have to come to the stationary phase. If it is normal, stationary also P, that means polar. Normal இருந்துச்சுன்னா in the peak we have to merge with polar. Stationary phase is polar and the mobile phase is non-polar. Here in the normal phase chromatography, the mobile phase is non-polar and the stationary phase is polar. Likewise, the last question, in the reverse phase chromatography, the mobile phase is dash and the stationary phase is dash. As I told you earlier, if it is reverse means P should not come here in the stationary phase, that means non-polar. Here it is polar. The answer for this, in the reverse phase chromatography, the mobile phase is polar. Mobile phase should be polar for the reverse phase chromatography. Stationary phase is non-polar. So along with this, we have to keep it in our mind. We have to learn one more things. The stationary phase, that means a mobile phase. A mobile phase, normally we use the solvents. Solvents, there are about 10 solvents with varying polarity. Before the examinations, we have to keep it, we have to read solvents order with varying polarity. That means from the non-polar to highly polar region. Around 10 to 15 solvents are there that we have to remember or study before the exams. Questions have been asked frequently based on these concepts. Regularly they are asking questions on these concepts. So these are the 10 questions, very key points of the second part of this unit 1. There are also other things are there, but I have mentioned very important things here. I hope this session will be much more useful to you. We'll see in the next session with other very important key points. Thank you so much.